Alright, in this video we're going to talk about different characteristics of polynomials. There's a lot of definitions, a lot of terminology, so I'm going to try to make sure I explain everything. If you need to go back, make sure you go back and check things. Alright, so the first thing we're going to do is we're going to look at this entire, see if I can get this, yep, the whole thing, pretty much got it in. So the first thing we're going to talk about is the degree and leading coefficient. And these are two different things, but they revolve around the same thing. Now, it does not matter what order they're in. So don't just think it's the first exponent. We look here, we have an exponent of 1, 2, 3, this one has 0 because it's got nothing, and this one's 4. Degree is the one with the biggest exponent. 4 is the biggest exponent. So 4. So you want to write your answers kind of like this. The degree is 4. The leading coefficient, now all these are coefficients. These are all coefficients. Every single one of them. But the leading coefficient is a number that goes with the number with the highest degree. So since 4 is my degree, leading coefficient is 8. So remember, degree is the highest exponent, leading coefficient is the number in front of the variable with the highest degree. Now, remember, this is called function notation. Now what that means is whatever is inside the parentheses goes in for every x. So if you see something like this as a 2, you plug it in for every 16, I can't think really clear. What it means is you plug it in for all the x's. So what I did was I wrote them out and I did the next step for you. So you just have to make sure. Remember, in a problem right here, you have to take 2 cubed, meaning 2 times 2 times 2, which is 8, then times by 5, and get 80. 14, 40, 6 plus 128. This would give me 54. 48 plus 128. I'm doing my math quick, so if I make a mistake, that's my fault. 6, put the 1, put the 1. Oh wait, no. 1. So it should be about 176. If not, it's because I'm going really quick. But the basis of it that you put 2 in for every x. That's the biggest thing, and make sure you stay organized. Use a calculator. So the other thing we're going to talk about is end behavior. Now we do 2 problems of end behavior, and I'm going to mix in a few other things. Now first we're going to look at this graph here. First off, to note a couple things. This has 2 zeros. And remember, a 0 means it crosses the x-axis. That's number 1. Another thing, this is an even degree. And the reason it's an even degree is they are both pointing in the downward direction. Even degrees point in the same direction. Doesn't matter if it's up or if it's down. They point in the same direction. Now, remember, the way we talked about in class is that you write end behavior to look like this. Oops, not like that. Plug that number in. So what this means, as x goes to infinity, meaning as x, we move to the right of my graph, where does my arrow point? Obviously it points down. That is in the negative infinity direction. As I move to the left, meaning as x goes to negative infinity, where does my line go? Well, it goes down. So it's also negative infinity. So you notice that they are the same ones. So this is a big thing. So if we're looking here, first we look at the zeros. We have 1, 2, 3 zeros. Look there. Now we know it's an odd function because it's pointing in the opposite directions. It does not matter. It can go up here or over here. Different directions. So remember, you should always have your end behavior look like that as x approaches infinity. So if we look here, as x goes to the right, that means my arrow is pointing in the downward direction. So it's negative infinity. As x goes to the left, my arrow points up, so it's positive infinity. So a lot of stuff going on. Zeros, even around, and also end behavior. A lot of stuff going on in this video. Make sure we review it.